This conference will now be recorded.
There we go. This conference will now be recorded. So that's just so that anyone that hasn't been able to get here this afternoon, that wants to view it later on, Sarah will be able to provide a link. So that's jolly good. So today's quite a momentous day. If you're not listening to this live, I'm recording this on the afternoon of, let's see, the 4th of November. So the results from the presidential election in the United States are coming in, and it does look incredibly close. So it's all very exciting, and I'm sure we'll all be looking at the news later to try and find out what's going on with that. But anyway, that's not what we're here to talk about today. We're here to talk about VoLTE. So I'm going to take probably a little bit over an hour just to chat about this. I'm not going to take your questions as we go through, but if you want to put them into the chat window, what we'll do at the end, I'll leave a little bit of time at the end, so I'll try and talk for maybe just a little bit over an hour, and that will leave some time for any questions that you may have at the end. Okay, so there we go. So that's what we normally do with our webinars. Okay, so if you do have questions, feel free to type them in, and I will do my best to get to them all before we wrap our session up today. Okay, so VoLTE. Let's talk about that. It stands for something. It's another acronym, I'm afraid. So it stands for Voice over LTE. So in our session today, I'll talk a little bit about why we need it, reasons that we're going to be doing this, and many operators are already doing this, I have to say. I'm sitting here presenting to you. I'm sitting in the United Kingdom. I'm sitting in a little tiny village called Milton Bryan, which is right in the middle of the UK, where it's all very green and lots of farmland around where I live. And LTE is actually quite mature in the UK now. So we've got a pretty good LTE network covering much of the country. And I'll talk to you about why all of the operators in the UK and many other operators around the world have rolled this out and have launched it. Okay, so that's the first thing. And then what I'll do, we'll open the lid, open the hood, the bonnet, whatever you want to call it, and have a look inside and see the sort of technology that we have to have inside the network in order for us to have this technology working. In order for us to have this what sort of nodes, what sort of networking do we need to have? So we'll go through that. We'll go through the architecture. I'll go through roughly how it works in very general terms. So we'll talk about the protocols that are used, and I'll run through again at quite a high level, nothing too deep and difficult, but I'll run through some ladder diagrams of some of the signaling processes that go on in order to do some of the main things. So we'll talk about registration, we'll talk about making a call, that kind of stuff. And lots of time for questions at the end as well. All right, so that's the plan this afternoon. So without further ado, hopefully you can all see my slide. Hopefully, I'm hoping you can. If you're able to do that, perhaps you'll give me a big tick or something like that against your name. I'd appreciate that. If anyone can do that, just let me know that you can see my slide. That would be very helpful. Tarek, did you want to say something? Just confirm for us if you can.
No, sorry, I'm just confirming that I can see. Sorry.
You're a very good man. Thank you very much indeed. All right, fabulous. Thank you. It's good to know, because actually from the outside, you know, if you were standing outside my office door looking at me here, you'd just see me talking at a blank screen or talking to a screen. So it's nice to know that there are actually some people on the end of it. So thanks for that. All right, so let's move on. Let's have a little chat about, first of all, the reasons that we would deploy LTE. Okay, so there's a few reasons, reasons to do with what we call these OTT or over-the-top providers. That's a service which is very popular, OTT. So things like, I'm thinking about things like Skype, perhaps, and things like WhatsApp, hugely popular. But WhatsApp is not only messaging, isn't it? It can provide some kind of voice over IP service. Okay, so they're able to provide that. So it would be nice if the telecom companies could provide something to compete with that. And that's very much where VoLTE fits in from that point of view anyway. The other thing to say is that carrying our voice traffic as voice over IP traffic is much more efficient. So before I move on and talk about something else, let me just get me a little laser pointer here so I can point at stuff. You know, why is it more efficient? Well, let's think about a normal conversation. You know, when we have a phone call set up using what we would call circuit switch technology, so going through a traditional switchboard or mobile switching center, MSC, what happens is some resources are reserved from, if it's you and I having a conversation, some resources are reserved so that I can talk to you, but also some resources are reserved so that you can talk to me. And they're in place so that at any time you can say something or I can say something and the other person would hear. So with a circuit switch connection, we set up a two-way street. Now, normal people having a conversation, we take it in turns, don't we? One will speak, then there might be a little gap, and then we swap over. Then you say some things, and I'll think about it and respond to what you've just said, and then you'll do the same. But most of the time, there's only one person talking. Now, what does that mean? In practice, that means at least 50% of our resources are not utilized. At any one time, probably only one of us is talking. So the best it can be is 50% utilization. But actually, it's worse than that, isn't it? Because there are gaps between the words. There are short periods where I just think about what I'm going to say, little periods of silence. Okay, so in actual fact, it's not 50% at all. It's more like, you know, 30, 35%, something like that, maybe 40% if we're all really sharp and on the case. Okay, so you know, that's the position that we're in. So it's actually really inefficient to carry traffic in that traditional circuit switch method. So carrying it as a voice over IP application is much more efficient because we're only pumping data into the network when we've actually got something to say. Okay, so it's much more efficient. Now I'm just looking at the chat box here. Tejas is saying near Saturn have entry gate on the fifth dimension to connect to the next parallel universe. I'm really pleased for you. I'm not really sure what that means, but thanks for sharing it anyway. I appreciate that. Okay, so we're saying that voice over IP and VoLTE is an example of a voice over IP application. All right. So we're saying that voice over IP is significantly more efficient. So that means that we get more network efficiency means we get improved capacity. So for a given investment, we'll get more capacity from a VoLTE network or a voice over IP network than we would from a traditional circuit switch network. Okay, so that's the idea there. Now the other thing is, if we're talking about traditional circuit switch voice, then the quality is sort of pegged by the quality that's available from the PSTN, the public switch telephone network. And that's the kind of quality that we would get from a 64 kilobit per second pulse code modulation channel. So we're kind of used to that. That's the sort of quality we get from a typical voice call. Okay. Okay. Now, voice over IP applications are not limited in the same way. So we can actually send, or we can actually use much higher resolution codecs there to carry our voice. So we can have, you know, high fidelity voice. We can have high definition voice over a voice over IP network like LTE. So again, that's another reason perhaps why we might want to do it. There's a more fundamental reason though. For an LTE network, the LTE network only provides us with an IP connection. LTE networks do not support voice in the same way that GSM does or the 3G networks do. Okay, so the only option that we have if we're going to use an LTE network is to have some kind of voice over IP application. And you know, a great way of doing it, as we'll see later on, is to do this thing called VoLTE. All right, so that's rather good. All right, so those are all good reasons for us to embrace and adopt VoLTE. So if we look at the way that the networks have evolved, our 2G GSM network only had a circuit switched or voice core network. Okay, our 3G network was able to support voice in the same way and also support data in a sensible speed. But as I've just mentioned, LTE does not connect to our traditional voice core network. It just doesn't provide that service. So all we're going to be getting from our, just get me a pen here, all we're going to be getting from this connection is going to be an IP connection. All right, so that's what's going on. So we don't have the option of doing voice in the traditional way. All right, so the only option really is for us to have some kind of voice over IP application running if we want to carry voice services over over our LTE network. All right, so LTE is data only. I couldn't have put it better myself. There we go, right. So LTE, data only. Fabulous. So let's have a little look at very high level at the architecture. So what sort of nodes are we going to have? Well, hopefully most of this diagram is very familiar to you. Most of this is just a standard LTE network. So let's talk about that. Over here on the right-hand side, over here, and that side of the line, we've got what we're calling our EUTRAN, Evolved UMTS Terrestrial Radio Access Network. Okay, so that's basically our 4G radio access network, our 4G RAN, okay? And that consists of a whole bunch of these eNode Bs, evolved node Bs, all connected together using this X2 interface. No scary stuff there, that's all right. And this stuff on this side of the line here, we would refer to this side of the line as being our core network. All right, so these nodes in here are very much our core network. Now we divide it into two parts really. We call this the CP being the control plane, and we call this side of things the UP. So I could draw a sort of a dotted line down the middle here between these two boxes, okay? And the control plane is on this side and the user plane is over there, okay? So if I was to make a connection to the outside world, and I'm going to use a different pen for this, I'm going to use, let's have a look, see if I've got a highlighter, that would be good. Right, so if I make a connection from this phone here, it would go through one of these particular cells, then it would make a connection up to the SGW here, and then on to the PGW, and from there to the outside world somehow or other, okay? So that's what's going on. That's the route that it would take through the network. So the MME, the mobility management entity here, is taking care of taking care of all the signaling. So our NAS signaling, authentication, attaching to the network, registering, all of those things will be dealt with by the MME, the Mobility Management Entity. And we've got this serving gateway and packet gateway taking care of the user plane. Okay, so that's standard LTE networking. Now over here on the left-hand side, this box over here on the left, we're calling it the PCRF, the Policy and Charging Rules function. That's like the policeman of the network. It's ensuring that our different classes of user and our different classes of traffic are dealt with in the correct manner. Okay, so that's that one. So if we make a voice over IP call, it will be the PCRF that ensures we get the correct quality of service and stuff like that. Okay, so that's what's going on there. So that's the standard stuff. Now, a couple of things I want to bring to your attention. We've got this functionality over here. So these are what we call non-LTE technologies. So we've got UMTS, which is effectively our, get the pen back, that's effectively our 3G. So this is 3G, right? And this is our Wi-Fi. There we go. That's our Wi-Fi network right there. Now, in a moment, when we start to talk about VoLTE, one of the alternatives I'll offer you is, rather than using a 4G cellular connection, it would be just as easy for us to provide that connection over a wireless LAN. So that's where voice over Wi-Fi and things like that come in. Now, actually, I'm using that at the moment. In the UK, I'm a subscriber to the EE network. The EE offer VoLTE services, but they also offer voice over Wi-Fi services. So when my phone recognizes I'm at home, what it will automatically do is connect me to the EE core network here via my wireless LAN, my home Wi-Fi network. So that's pretty cool, isn't it? All right, so hopefully there's no news there for everybody. So I guess the new functionality that's particularly down to voice over LTE, VoLTE, it's this stuff here. It's the stuff to do with the IMS. So we've got to spend a little bit of time today talking about the IMS, what it's all about, and how we might go about using it. Okay, so that's a big part of what we're going to be looking at in this webinar this afternoon. All right, so the normal services that LTE provides, there's a number of them. It might just be something like, just connecting to the internet, quite possible. Just go connect to the internet and do whatever you like. So go look at some videos if you want, go to YouTube and have a look at those, or, go on Facebook and do a bit of that, normal web browsing. Now, the operator themselves may offer some content, although that's not so common these days, actually. I mean, it's possible, but not very common. What you might find is that the telecom company partners with a third-party organization. So there's talk of there being tie-ups between telecom companies and, for example, newspapers. So newspapers are finding it quite difficult to take their offering online, taking their offering into the digital world. So one of the hot topics at the moment is, how could a newspaper that wants to sell digital content, how could it partner with a telecom organization? Well, how could it partner with a Vodafone or a Zain or one of those organizations? Well, what could happen? The newspaper could be the content provider, and the telecom company could be the what could we call it? The delivery network or the distribution channel for that content. And what they could do is they could partner, and they could perhaps revenue share. So perhaps, you're not going to pay $100 a year to read a newspaper, but maybe you'll be prepared to pay 10 cents or 10 pence today to access their content today. Okay, and I could partner with the telco to do that, and that might be a very good fit. So there are lots of opportunities like that. So it might be operator owned content, or it might be operator managed content, as I've just described, like a partnership or something like that. The other thing that we could provide access to is perhaps, you know, third-party content, maybe at a special price or a discount price. So, for example, when you sign a contract, for example, for a year, Vodafone may be prepared to give you a subscription to, I don't know, the Premier Football League or something like that, so you can watch Premier League football matches. Or maybe they provide you with a year's subscription to a music service like Spotify, for example. So again, there might be some services like that, some value-added services that we also can get access to, as well as our normal web browsing content. So there's that, we could also include in there, you know, voice services. So if there is an IMS, an IP multimedia subsystem inside the network, then we could use that, we could leverage that to provide voice services as well. All right, and that's what we find. All right, so that's a big enabler of VoLTE. Now there are some other bits of technology that would be equally important in an LTE network, and it's not really the subject of this webinar. But you know, we could spend a lot of time talking about service delivery platforms, and what that tends to involve is some rather large caching capabilities, very much closer to the end users. So you might put some caching somewhere, you know, very close to the radio access network, and you know, stream content from there. Okay, so that's one of the things this service delivery platform might be you know, very good for helping with. Okay, the network itself, all that LTE is going to provide really is a high capacity network. So it's going to provide high capacity, as I've just mentioned, but it also means it's going to have to provide it as a low latency service. So some of the things that we're going to want to do with LTE require the delay, one trip through the network, to be as small as possible. Okay, so for example, for voice calls, we want the round trip delay probably to be less than about 400 milliseconds. If on a voice channel, the delay starts to get over half a second, then we start to notice. You know, if your voice channel has a delay of a couple of seconds, is that a problem? Well, actually it is, yes, because if you both start talking and there's a delay of 2 seconds on the channel, 2 seconds after you both start talking, you both realize at exactly the same moment that you've both started talking. So what do? Well, you both stop talking, don't you? Exactly 2 seconds later, you both realize that you've both stopped talking. So what happens next? You both shut up, and you know, and so on. Rinse and repeat as many times as you like. Okay, so that's the issue. So you know, not only does it need to be high capacity, it also needs to be low latency. Okay. Now the voice channels themselves are not very demanding. You know, for 100 kilobit per second connection, that would comfortably carry a voice call at quite nice quality. Okay, so we're not after, you know, megabytes of capacity, but we are asking a consistent service that's guaranteed over a period of time with a low latency. That's really what we require from the network. So there's two parts to our voice over LTE call. We've got stuff here that we would call UP stuff, user plane stuff, and that's the actual content of my voice. So if you're listening to this live, you're actually listening to my voice in a live way. So my voice is being chopped up into little packets of data, and that's being carried over the internet, and your laptop or whatever you're watching this on, listening to this on, we'll have to do the jigsaw puzzle. We'll have to take all those little packets of data and glue them all back together again so that it all makes sense, okay, so that you can hear what I'm saying. And what we're saying is the contents of the voice, what we call the media here, is carried over this blue pipe. Now that's not the end of it, because we've also got this red pipe. So what's that red pipe all about? Well, we refer to that as the control plane. So that's signaling. So if someone wants to make your phone ring, if the IMS here wants to make your phone ring, it needs to send a message to your phone saying, hey, someone wants to talk to you. Do you want to talk to them? Yes or no? And at that point, a little window will pop up on the screen of your phone. You know, green button for yes, I want to talk to them. Red button for no, I don't want to talk to them. So you get invited to have a call, and then you'll indicate yes or no. And again, that will go on the red channel up here, the control plane up to the IMS. And then we decide whether or not, we're going to accept the call. That goes back to the IMS. And if we accept it, then this blue pipe will be established for us. If we reject it, then that's the end of it. The call doesn't get connected to us. We may be connected to somewhere else, like maybe our voicemail, for example. All right, so there's two parts to this. There's the control plane, which is the red pipe, okay? And we've got the user plane, which we would term the blue pipe there, okay? So there's two parts to it. Now, we're making a strong distinction between the IMS here and the rest of the LTE network. Now, in reality, the IMS is an external network to our 4G core network. So the connection to the IMS will go through a particular place, a particular connection. And that connection, we refer to that as an APN. So that APN will probably be called IMS. So APN is an access point name. That's the doorway that we leave the network through. But all the IMS services in the UK, they all use the same APN, or the same name of APN, and that's IMS. All right, now, you can think about APN as the doorway that you leave the network through. So if you leave through the doorway that's marked internet, then that's where it takes you. If you leave through the doorway that's marked IMS, then that's where it takes you. All right, so this is leaving through the IMS door. All right, this door here is the IMS door. All right, there we go. So off to the IMS. So the IMS is an external network to the 4G network. It's outside the wall of 4G, right? But it's vital for us to have an IMS if we're going to have voice over LTE services going on, right? So what's the functions of this IMS? Well, we've got a box in here called a CSCF, a big long acronym, I'm afraid, call session control function. And not happy just with one, we've got probably 4 or 5 different flavors of CSCF. So we've got a serving call session control function, an interrogating call session control function. What else have we got? A serving, so we've got proxy, call session control function, serving call session control function, interrogating call session control function. We'll also have an emergency services call session, loads of them, different flavors of this. Well, actually, it ends up being quite complicated the way it all hangs together. But the functions of this IMS, one of the things that we're going to do is we're going to register our VoIP users. So if our phone over here is a voice over LTE capable phone, then when we turn it on, what it will do, it will register in the IMS to say, I'm online now, hi, you can route phone calls to me. Okay, so that's what registration is all about. And also we can deregister. Actually, there isn't a deregister command in SIP, but I'll talk about that in a minute. The protocol that we use here is called SIP, by the way, Session Initiation Protocol. There's a register message in SIP. There's no deregister message. So if you want to deregister, what you do is you register with a time period of 0. So that immediately expires, so therefore you deregister. That's the way that we do that. Then when we want to make a call, call session control function, our IMS functions here, process that and actually build for us this blue pipe, this user plane pipe to carry our call. All right, and once that's in place, we manage that. Now, manage it, there's lots of things that we do to manage it, but one of the things that we'll do is we'll collect billing records for it. So we'll collect CDRs, call data records for the phone calls, okay? So that means we can bill for these services in the normal way. Okay, so all kinds of stuff like that. The LTE network itself is the manner that these pipes will take. So when we establish our control plane here, that's what we call a default bearer. So it establishes that initial bearer that we're going to be using. By the way, bearer means the word to bear, the verb to bear means to carry. Okay, if I bear a load, I bear a weight, or I bear responsibility, okay, it means I carry it. So a bearer is simply something that carries something for us. So these are pipes, effectively. It's a good analogy. These are pipes that carry our data or our signaling, whatever. So the LTE network is going to provide those bearers, those pipes for us. It provides it in an always-on manner. So that means the handset is going to have an IP address. Now, normally with IMS, we're using IP version 6. Most of the logs, the system logs I've seen for voice over IP calls, we would have an IP version 6 address allocated to us. So it's very much an IP6 application that we're using. And it's going to provide this pipe. It's going to transfer this SIP signaling, SIP being the session initiation protocol. Okay, that's the language that we use when we're talking to the IMS. All right, so invite would be a SIP message. We've got some keep alive messages that go on. Okay, if I want to have a phone call with you, I will send you an invite message. When you want to end the call, you send me a message, and it really is called this. It's called bye, B-Y-E, bye, see ya. That's really what it's called. So actually SIP is quite friendly to read. You can kind of see what's going on. All right, and there we go. So those are the basic functions that we have inside the IMS there. So looking inside the architecture, you can see that we've got some different flavors of call session control function, as I mentioned a moment ago. Now, the proxy call session control function is always in your local network. So if you're in your home network, then your proxy call session control function will be in your home network. In a roaming scenario, the proxy call session control function will be in your local network, which means it would be in the visited network. So that's why we're saying here. So if it's non-roaming, you'd be in your home network. If you're overseas and you're roaming, it would be in the visited network. Okay. Now, the serving call session control function, that's this one in the middle here, this chap, that's always in your home network. All right, so the proxy one is always in the local one. The serving one is always in your home network. So in a roaming case, they would be located in different networks. Now there is a box in the middle here called the ICSCF, the interrogating call session control function. Okay, the interrogating call session control function is the call session control function that would be on the border of your home network. So that fulfills two functions really. It's the address that we provide to all our roaming partners, okay, as our access point to our call session control function, and that doesn't change. So what it means is we can leave that constant and we can change the infrastructure behind it without having to inform all of our roaming partners. And that's a big advantage, actually. Also, it performs a role which we call infrastructure hiding. So by presenting the interrogating call session control function to the outside world, it disguises what goes on behind it. So if you're a hacker, you want to do some damage to this network, you really want to know the structure of the network, don't you, in order to do that? Well, the interrogating call session control function hides that from you. Right, now, we've only put one on here, but look, in a real network, there will be absolutely dozens and dozens of firewalls there. You'll also find that there's a number of what we call GWs. GW is gateways. So we've got a media gateway here. You'll also find that we've got signaling gateways as well inside the network. Okay, when we span to other networks, we're going to go through this border gateway. So that we'll go through this thing called a border gateway control function. This is connecting to an LTE network over here. So that's 4G. Okay. We might have connections that are going out to Wi-Fi, for example, or what we would term non-3GPP access networks. All of those are there. Now these, ASs, these are application servers. So what sort of examples might that be? Well, that could, for example, be your voicemail platform. Okay, so that application server might just be a rack full of Blade PCs, HP Blade PCs, and some big hard drives, and that might be where your voicemails get stored if you're using this for your voicemail services as well. Okay, so there we go. So there's lots of features inside. Now, the other thing I just need to mention is this little box up here. Now, we're probably all familiar with an HLR, home location register, but in VoLTE, we would term this an HSS, a home subscriber server. So it fulfills a role very similar to the HLR. It's just that for an LTE home location register, we would generally call it an HSS, home subscriber server. Okay, so that's the internal architecture of the IMS. Now, there's a lot more I could say about this. I do actually run a 3-day course just basically on that diagram there. And so if you really want to know the ins and outs of what's going on in there, that's the course for you. However, only do that course if you really, really want to know, because it's 3 days of your life that you'll never get back again. Okay, so only do it if you really want to know. All right, so wow, look at the time. The time is flying past. What I'd like to do for you is just go through a few of the processes and procedures that we have inside our IMS, our VoLTE system. So I'm just going to put all this up, and I'll just talk you through it. I can annotate it then much more easily. So let's just get my laser pointer back. There we go. All right, so let's imagine that our objective is for a phone call between this UE, this user equipment up here, this phone, and this phone over here. So if that's what we're trying to achieve, both of these, the first thing that needs to happen is both of these phones, this one and this one, both of these phones need to be registered on the network. So there needs to be a registration procedure. Now that registration procedure is fairly quick. It's not going to take ages and ages, but there may be a few steps involved. So, for example, this registration process almost certainly will include authentication. So not only will the LTE network authenticate the handset, but so will the IMS. So we've got some registration going on here. you can see that, you know, authentication is very much part of that process. All right, so it will register with the LTE network, okay, and probably it will be authenticated there as well. We will establish our default bearer. Now, what's the point of that? Let's just discard those for a moment, get that back there. I'll take us back a little bit. Right, I said a moment ago that we needed to have this pipe in place, this control plane in place. Now, that will use this thing here called the default bearer. So that default bearer is effectively our control plane that we're going to use to send signaling messages up to the IMS. Okay, so we set up that default bearer, okay, and then we're able to discover the sort of services that this particular IMS provides. Okay, so, you know, what does it? Does it provide high definition voice? Does it provide video calling? Is there an email service? A voicemail service? All those things about it. What is it capable of? All right, so that's we would discover that at that point. Now, obviously, before that happens, again, this isn't really IMS stuff. This is to do with the air interface. So RRC connection setup, RRC connection request, RRC connection setup, RRC connection setup complete. That's an exchange of 3 RRC messages to set up our original signaling bearer between our phone and our base station there. And all of this stuff over here is effectively us communicating, the handset communicating all the way out. So I'm just going to draw it on as an arrow here, all the way out to our PCRF, the policy and charging rules function. I said earlier on that that PCRF was effectively the policeman. So at this point, what have we got? Well, we've got our default bearer in place. So we've got a pipe that goes all the way out to the IMS. We've been authenticated by the LTE network. Okay, a default bearer is in place, and we know roughly what the IMS network that we're connecting to is capable of. Right, so having done that, what's the next step? Well, the pipe's in place, so we can then go ahead and register with the IMS. Now, at that point, we are checking to make sure that our subscription allows us to connect to the IMS, right, to the call session control function, and also any other services that we subscribe to in our subscription, right? So maybe that's voicemail, maybe it's something else. I don't know, it could be anything, couldn't it? Any kind of application. But it checks that we are allowed. Okay, so it authenticates us. Once authentication has been completed, it does the authorization piece. So once authentication is answering the question, is it really you? And then once we've answered that, we do the authorization thing. What are you allowed to do? Okay, so that's the next step here that's undertaken in this stage. Having done that, bear in mind the objective that we said is we want to have this phone call in place here. So that's ultimately what we want to get to. But what are we going to do? How are we going to establish that? Well, we would go for this step. And that is effectively an invite message. So an invite message would be passed from the handset all the way up to the serving call session control function. Now, in a roaming scenario, that may mean it goes through a proxy call session control function, interrogating call session control function, and finally to the serving call session control function. So just to go back to our previous case, you know, if we were in a roaming scenario, our route might be from the visited network through the proxy call session control function, the visited network, all the way back across the international network, through the interrogating call session control function to find our serving call session control function right there. Okay, so having done that, having sent the invite message off, the next thing that will happen is that invite message will be passed to this other handset. Now, we've not shown the other leg of the call. We haven't shown where it goes after that, but there will be a sort of a mirror image of that diagram that goes through the other handset's network, and the invite message would be passed to this other UE. And it's got two options then. Either it says, yep, I'm happy to have the call, in which case it sends a 200 OK message back the other way, or it says no, a cross here, that's supposed to be a cross, in which case we send a reject message back the other way. Now, assuming that the other person wants to talk to us, we send a 200 OK message back, which results in this step, a dedicated bearer being set up. The pipe is then in place between these two phones. They've exchanged IP addresses and codec details and that kind of thing, port numbers, and away they go. Right, they have their conversation. Right, and that's our call in place. Now, what we haven't shown here is what happens when we want to end the call. But effectively, what will happen, one of the phones would send a message that says bye, BYE, bye. And what that results in is all the resources that were reserved for that dedicated bearer to be released, and we would just go back to the situation where we only had the default bearer. Okay, so while the call is going on, we've got both the default bearer for signaling and the dedicated bearer to carry our traffic. When the call ends, the dedicated bearer is released and we're left with the default bearer. Okay, so there you go. There's the default bearer that's carrying our SIP signaling. And if I can just put the other part on the diagram. No, I'm sorry, I thought there was another pipe to come on here. Sorry about that. When a call takes place, a dedicated bearer would be built here, okay, as we had previously. Let me just go back and I'll show you that slide. So as we had here, so the dedicated one, the default one is the red one, and the blue one here, bluey purpley color, is our dedicated bearer. Okay, let's just get back to that place. Right, so what we're going to do is we're going to set up this default bearer, and we want to make sure that it has a quality of service that's appropriate for SIP signaling. So what does that look like? Well, the quality of service that we need, or these are the different options that we have, and it ranges from the most real time at the top here, right down to the least real time at the bottom. So for things like an FTP session, I would happily use QCI number 9, okay, like a real background task, highly reliable, but quite a high delay, one trip through the network, quite a high delay. So probably wouldn't want to use that for SIP signaling. SIP signaling is much more important than that. So actually, we use class 5, QCI class 5 for our SIP signaling, okay? So let's show you that. So here is our default bearer. Our default bearer there is going to have a QCI value of 5. ARP, that's allocation and retention priority, is 9. So we really want to hang on to this. Allocation and retention priority says, you know, how important is it to you that you get it? That's the allocation priority, and the retention priority is you hang on to it. You know, and we're saying that this is very important. So let all the other things go first before you let go of this this particular pipe. And the data rates that we need from it are pretty modest, actually. It's a bit of signaling. It's not huge. You know, 0.5 meg in the uplink, meg in the downlink direction. That's perfectly okay. Okay. All right. So again, that's not a guaranteed bit rate. It's a non-guaranteed bit rate for that. So sort of bursty traffic. What about the media pipe, the dedicated bearer? Well, that's got different characteristics. And the main difference is we want to make sure that our dedicated bearer is a much higher priority. Okay, so it's very real time. So if we go back to our table of a moment ago, this table here, we're saying, look, for conversational voice, that's the most real time of all, we want to use a QCI value of 1. Okay, now that gives us a high priority. It gives us the lowest latency or very low latency. Okay, but we're not too worried about errors. So for our signaling, we will be very worried about errors. So for our SIP signaling, we've got a bit error rate or packet error rate of 10 to the minus 6. That's 1 in a million. For our actual media, our voice traffic, we're saying, I'm not that worried. If 1 or 2 of the packets go missing or got errors in them, yeah, that's okay. I can live with that. All right, so we're saying packet loss 1 in 100, 10 to the minus 2 is 1 in 100. Okay, but a high priority and a low latency. All right, so let's just go back there a moment. There we go. So we're using QCI 1. We're saying voice calls have the highest priority here. That's ARP9. And we're asking it to provide us now not a peak throughput. We're asking it to provide us with a GBR, a guaranteed bit rate, with a mean bit rate of 32 kilobits per second. Okay, so absolutely fine. Now there's a couple of options here. We can either use IP version 4 addresses, which might look like that. It tends not to be what we use. It tends to be in real life that we would use IP version 6 for our IP, our IMS connections, actually. So you're much more likely to see that in real life. So just going through these procedures in a little bit more detail. So we registered with the LTE network earlier on. We built our default bearer. So what we would then want to do is register with our serving call session control function. Now, just to make this a bit more interesting, a bit more spicy, let's imagine that I'm in Q8 at the moment. So maybe my home network perhaps is in the UK. So let me just write that on. So my home network is EE in the UK, but I'm on one of my regular visits to Q8. So I'm sitting in my hotel in Salmiya. The proxy call session control function would be in Q8. I'll put KU here for Q8. So my registration message would be passed to the proxy call session control function somewhere in Q8 city. Okay. Then it's going to look at my IMSI and say, well, hang on, he's not a Q80. He's not on a Q80. It's not a Q80 network SIM card. It's not Viva or Zain or Do. He's in the UK. So we need to communicate with the UK. So what it would do, it would look in its IR21 document and say, right, how do I get hold of EE in the UK? And it would therefore know the address of this box, the interrogating call session control function. So my registration message would be forwarded to the interrogating call session control function on the border of the EE's network, on the border of EE's core network in the UK. Then there might be some conversations that then go on to say to the HSS, so where's the HSS that looks after Paul? That would be a question that is asked of the HSS. The HSS would respond with the serving call session control function that looks after me, and therefore my registration request would be forwarded to my serving call session control function back in the UK that can look after me. Okay, so that now knows that I want to connect or register. So then we might do some security stuff, and the main thing there is authentication, authorization, the 2 steps really. So we'll continue to use the IDs and the keys and everything that's on the SIM card, but we will go through that and we will authenticate. All right, the IMS would authenticate the handset. At the end of all that, providing everyone's happy, a 200 OK message is sent back to the handset via the interrogating call session control function, the proxy call session control function in Q8 City. All right. Now at that point, I'm registered on my serving call session control function back in the UK, and I can go ahead and do whatever I want to do. All right, so I'm registered now. Okay, so just a few more things. Let's have a quick look at a typical phone call, and we'll probably be ready to even think about wrapping it up then, okay, when we've had a look at that. So let's have a look. I've already registered. So what am I going to do? If I want to speak to you, so I want to talk to you, and let's imagine that you are also an IMS user, a VoLTE user. What's that going to look like? Well, I'll get your phone number out of my phone book and hit the green button, and that's going to result in an invite message going from my phone in Salmia to the proxy call session control function in the middle of Q8 City. And that invite message is going to be forwarded back to my serving call session control function in the UK. Now, I've missed out the interrogating call session control function in the middle there, but it would almost certainly go through that. Then the invite message would be forwarded to you. So at that point, a little window would open up on the screen of your phone, and it would basically say, Paul's calling, do you want to talk to him or not? So green button for talk to him, and red button to decline the call. Okay, so what have we got going on? All of these things are protected by timers. So you might send back this message here just to say, you know what, I'm looking at that. And we might send a message back saying progress, that's this one. And then we might send back this one, this is called a PRAC. PRAC is a provisional acknowledgement. That PRAC is an acknowledgement of that 183 message, that session progress message. And it's just to stop things timing out, okay? Then at the end of all of that, we're going to build our dedicated bearer. When everything's happy with that, we're actually going to hear the phone at the other end ringing. Now that's quite important because let's see, if I phone you in the UK from Q8, then I would expect to hear a UK dialing tone. So that dialing tone is going to be sent to me from this destination system. Where's that? If I'm calling you in the UK, that's in the UK, isn't it? Okay, your network. If I phone someone in the States, I want to have a chat about the the result of the US election or something like that. The ringtone that I would hear would be a US ringtone. So actually, this dedicated bearer needs to be in place for us to hear that destination ringtone. Okay, it's actually a one-way pipe. It's on in the downward direction at that moment, and which we acknowledge. And at the end of all of that stuff, we can go ahead and have our phone call. All right. Now there is an example here. It's probably a bit small to see on the screen, but we've got an extract from some SIP signaling. All right, so again, I don't know how easy it is for you to see this, but it says this is SIP signaling, session initiation protocol signaling, and actually that's very nice and easy to read. All right, so let's have a look, see what we can see here. We've got some IP addresses and some port numbers and things like that. It's all very nice. And who it's to, who it's from. So some identities in there. You might have some via addresses in there as well. Okay, some various other bits and pieces in there. Okay, so what's allowed. This is an invite message. You can see that there. This is me inviting someone to have a phone call with me, perhaps. Now, inside, it looks here like it's inside it. this is called SDP, the Session Description Protocol. That's actually a wrapper that encloses our SIP message. And inside here, you'll have all the guts and gore, all the gory details of our connection. So what port number should we use? Okay, what's the port numbers we should use? What codec are we going to be using? Okay, so we're saying on port number 52090, you know, we want to be using a particular codec. Okay, we've got some information there about the codec that we're going to be using and so on. All right, so those kinds of things. So that's the SDP gives us all the nuts and bolts detail of the connection. And this bit at the top here is simply saying it's an invite and it's from this person to this person. All right, so SIP is actually quite easy to read, or quite straightforward to read. What I would normally do is spend a little bit of time. I mean, you could get these traces from something like Wireshark or something like that. And with Wireshark, you can set up your filters quite nicely. So depending on what you want to see, you would either show this SDP part, you know, if you wanted to see the details of port numbers and codecs and things. But if you didn't, you could just close that off and it could just be hidden from your eyes. And you could just have, you know, the top line information like, you know, this is an invite. Who's the A party? You know, who's the A party? This is the from, okay? From is the A party, that one there. Okay, and who's it to? Who's the B party? Here it is, it's that address there. Okay, that's the B party. We've got some timestamps on it and everything else, all right? So there we go. That's that forms the basis of our CDR, actually, that message right there. So it's one of the things I really want to talk about, and I'll probably shut up after we've dealt with this. Let me just see how many slides I've actually got left to cover with you. Of course, okay, that's fine. I think we'll stop there. So I'm going to go through this CSCF, circuit switch fallback, CSFB, circuit switch fallback. I'll go through that with you, and then I think we've probably done enough for today. So let me just talk about that. Circuit switch fallback. There's two reasons why we would do circuit switch fallback. The first one is there may be customers that you don't want to allow access to the IMS. Right? There might be a group of customers, and typically in the UK, that's maybe prepay or pay-as-you-go kind of customers. Generally speaking, they're not granted access to the IMS. That's generally the case, and there's no technical reason why they can't. It's purely a marketing reason why perhaps they're not allowed, but that's how it is in the UK right now. So if you want those people to be able to make phone calls, they're going to have to do this. They're going to have to let go of the LTE network, reconnect to the legacy network. That means fall back to the legacy network, make their call in the traditional way. So rather than them being connected to LTE, which is perhaps what they would normally do, okay, we don't allow them to, if they want to make a voice call, we force them to connect over here, and then their call would be routed in the traditional manner to an MSC, okay, and then out to the outside world, all right? Then when they'd finished their voice call, let's see if I can get an eraser. There we go. Let's see if we can rub that out. There we go. When their voice call is over, there it is. What they're going to do now is they are going to reattach to the 4G network. Now, if you are midway through, you know, watching a TV show or something like that on LTE, and then someone calls you, if you accept the call, remember that you're going to drop the connection to 4G, and you're going to re-establish your connection over here to 2G or 3G perhaps. And probably what that's going to do, it's going to pause your video. You know, if you're watching a TV show or a movie or something, you're streaming it online, and you're watching this big long YouTube clip or something. Now, if you're away for too long, that connection to the internet is going to time out, isn't it? So when you do come back over here, you know, when ultimately you do let go of that legacy network and you come back to 4G, probably that connection's timed out. So what you're going to have to do, refresh the page. So that means you then might have to scrub through the video to find the right place where you sort of viewed up to, okay? And that's okay, it's not great. I mean, you might have to watch the adverts again or something like that, I don't know. But it's not great, is it? So that's circuit switch fallback. So it provides a mechanism to allow people that don't have access to the IMS to still make their voice calls. Now, the other thing that can happen is I could be, you know, maybe I'm making my call. Let me just draw this on. Maybe I'm making my call through the 4G network, you know, off to the IMS over here. I'm making my call like that to the IMS cloud through the 4G pipe, and that's all working great, okay? So my call's underway. But what happens now if I drift out of coverage of 4G? If I drift out of coverage to 4G, what's going to happen is we're going to have to re-establish our connection like this. So the first thing that we do is we build that pipe through the legacy part of the network, and then we tell the phone, let go of that connection there, but re-establish on, it's a bit clunky this, isn't it? Please forgive me. Re-establish your connection like that. Now that's called something, that's, oh, sorry. Oh, jeepers. Right, one sec. There we go. Re-establish that, that's called something, that's called sorry folks. My mouse is playing tricks on me today. It's called something. I'm just going to write it on SRVCC. Single radio voice call continuity. That's what that is I've just described, okay? And it's effectively CS fallback. So SR, single radio, it's saying that the phone can only do one thing at a time. So it can't both be connected to 4G and 3G at the same time, okay? So when we move across, we can no longer use that connection there. We have to use this new connection that goes via the IMS, but through the legacy part of the network. And the other thing to say about it is the VCC is voice call continuity. So what we're saying is we're prioritizing the voice call, and keeping the voice call alive is really important to us. Okay, so that's SRVCC. So it's in those two cases really that we use this CS fallback technology. Okay, that's probably, I've been talking for a bit over an hour now. So I just really want to open up the floor really and see if there are any specific questions about anything I've talked about today. I'm going to have a look in the chat box here and just see what the questions are. If we can have a look at that, I will have a look at that. Let's have a look. Okay, right. Okay, so Teas, I hope I'm pronouncing your name correctly. Teas, I'm not sure really what you're talking about in those first few comments. They're quite funny, but you near Saturn have a, so look, near Saturn have entry gates to the fifth dimension to connect with the next parallel universe. Not sure what that means. We can network interplanetary communications infrastructures. Okay, Can you connect me to the universe? Reconnect me to the universe. Okay, not sure what that means. If I can, you can perhaps universe within us. Okay, how is this possible? I don't know. I'm not sure what that means. So how will I connect to the universe? Not sure what's going on here. Learn to go with it. Okay, no sound. Back now. Yeah, sometimes the sound comes and goes, doesn't it? We are very much at the mercy of the internet for all of this. So depending on, I've got fiber into my house, so I've got almost 1 gigabit per second into my house, which costs me a lot of money every month, but it's kind of worthwhile. But of course, I can't vouch for what happens between my internet service provider and the rest of the internet. So if the sound sort of comes and goes, it's kind of difficult. Okay. Right, so someone has said, can you send a PDF and the recording? Yes, if you have a chat with Sarah. So if you send Sarah an email, what Sarah will do, she will take this recording and put a header and a footer on it and that kind of thing. Make sure that everything's fine. Probably, I think, compress the audio as well, that sort of stuff. And she'll put it somewhere. She'll put it in a receptacle that you can stream it from. I'm really happy to share the PDFs as well. So I'll send Sarah a PDF of this and she'll make that available to you. So absolutely not a problem at all. Right. Can I call another, let's have a look, see what that says there. One moment. Can I call somebody in another country with IMS without additional roaming costs? Right. So the idea is with VoLTE is that it becomes just like their old circuit switch network. So what this is allowing you to do is to make traditional circuit switch calls effectively, voice calls, but you're not aware that there's an IMS taking care of this. It's all transparent to the user. Okay, so they will still charge you roaming fees. They will still charge you by the second for the call. They will charge you as if it's a normal voice call, which it kind of is, isn't it? But the benefit is for them that they get to carry all their traffic as VoLTE traffic, voice over IP traffic, rather than have to provision it as a circuit switch connection. So from a customer's point of view, this is going to be completely transparent to them. So it's not going to be any different. They don't do anything different. They use the same dialer on their phone. They type the number in, they hit the green button, and then they start talking. All right. So actually, I'm sorry to say that you're still going to be charged in the same way. So VoLTE is call via IMS. Is that correct? Yes, it is. Your voice call is routed via the IMS, and the connection is then made as a voice over IP application. So you would have a voice over IP client running on your smartphone, and it would be voice over IP end to end potentially if the other person's a VoLTE customer as well. Yeah, absolutely. All right. Can you send me the recordings? Yes, absolutely, as I've just said. Mercy Ship do health treatment port to port. Not sure what that means. Mercy Word also use movie Mulan. Great. I'm really happy for you. If there are any other questions, then please feel free. Type them in, and I will do my best to help you with that. If you've got anything about this content, otherwise, I will wrap it up pretty soon, and I'll see you all on the next one. I'm going to mute my microphone now. If anyone's got any questions, please feel free to type them in here, and I'll have a go at them for you. Okay, so let's have a look. For voice over LTE, I learned that we have 4 techniques: circuit switch fallback, SRVCC, OTT, and IMS. Yeah, that's correct. IMS is what it's really about today. Voice over LTE is all about IMS. IMS is the alternative to those over-the-top plays. Okay, SRVCC is what happens if you start your call as an IMS call and you need to hand it over to a legacy network. Okay, that's what that SRVCC is all about. And circuit switch fallback really is about, you know, what happens if you've got a customer that's an LTE customer, but you don't want them to have access to voice over LTE. What will they have to do? They'll have to do circuit switch fallback. Okay, so absolutely spot on. Teas, I think the answer to that is 42, actually. Any other questions? Any serious questions that I can assist you with? I'll be more than happy to try and help. All right, so fabulous. I'm going to mute my microphone now, and please feel free. Anything about this content you want to ask, go for it, and I'll try and deal with them. I'm not in a rush to go, so feel free. I'm going to mute my microphone for a few minutes, and I'll see if there are any questions, and then I'll try and deal with them. All right. Okay, so that's a really good question Monica's asking here. So how is critical communication provided over LTE? There's a couple of projects like that are underway, Monica, actually, about that. We call it the ESN in the UK. So ESN is the Emergency Services Network. So if you do a search for Home Office, and that's the government department that is dealing with that project, Home Office. And search for ESN, Emergency Services Network. Okay, and that's a really good case study of doing critical comms over over LTE. All right, so all right, so what it does, effectively is it provides some opportunity to, you know, prioritize that critical traffic. So with the ESN, they're actually sharing the radio access network with a commercial organization. So again, nothing secret here, but ESN will run on the EE network in the UK, and their traffic will go alongside normal users' traffic like my own. Okay. Okay, so yeah, ESN is the replacement to, absolutely, that's right. So ESN is a direct replacement of the old Tetra technology. I think Maha, you're quite an authority on that Tetra stuff as well, aren't you? So yeah. So what they do is they provide some higher priorities for those users. So their data will always take precedence over over normal users' traffic. Okay, so that's what that's all about, and that's kind of how they cope with it. They don't use VoLTE. They use something called push to talk. So they have, I think that's being provided by Motorola, actually, that part of the network. And so they have a push to talk application. So it works in a very similar manner to Tetra. So you've got tones and things like that that you hear, you know, when you press the push to talk button. You know, that's how, and that's because that's the way that most of the cops and the ambulance drivers and the fire crews, you know, use their Tetra radios right now. Okay, so that's why they're doing that. But that's how it's going to be. And I guess the main difference is that they can prioritize that critical, mission critical traffic over and above the run-of-the-mill traffic that we're perhaps used to seeing for the rest of the network. Okay, so I'm not sure if I've answered that question sufficiently, but let me know if there's a follow-up question. Please feel free. type it in, and I'll do my best to answer it for you. Okay, so I'm just going to mute my microphone, just give you a few minutes if anyone else has got some questions. If you have, fantastic. If not, then we'll wrap the session up. Okay, that's Roderick. That's not a problem. You're very welcome. Thank you for your comment. Good. Thank you. Thank you for that, Fanny. I appreciate that. Thanks, Maha. Thank you. That's all right, Tarek. You're very welcome. And Monica, thanks for your comments. That's great. Thank you. See you next time. Yep. Goodbye. Cheerio. Yeah, you're talking in SIP signaling now. Bye is the SIP message to end the call. So very appropriate that you've said bye. Yeah, excellent.